Good morning, everyone. My name is Shrila Nadla, and today I'll be presenting my interim report for climate winds. Uh, this project explores how machine learning can be used to predict weather conditions and identify signs of climate change across Europe. I'll walk you through our data, the algorithms that I've used, and the results I've achieved, and what would probably be coming next. The main objective of this project was to use machine learning to evaluate and predict weather conditions and potential indicators of climate change across multiple European weather stations. I have developed three key hypotheses. The first one is that there's a correlation between rising temperatures and extreme weather events like heat waves or heavy rainfall. Second, I expected prediction accuracy to vary by location due to differences in local climate patterns. And thirdly, I hypothesized that no single algorithm would consistently outperform the others across all regions. So these are guided on how I've selected and tested the models. Next, the data came from the European Climate Assessment and Dataset project. It includes observations from about close to 18 weather stations across Europe with data spanning from 1960 to 2022. This data has features like temperature, humidity, precipitation, cloud cover, etc. Before running the models, I have handled any missing values through interpolation and normalized the data so that the features could be compared on the same scale. This processing step was essential to ensure that each algorithm performed consistently. Although the data set is comprehensive, there are few biases that need to be aware of. There's temporal bias, since older records may have been collected using less accurate instruments. Historical bias, where older data can overshadow more recent climate changes, reducing model accuracy for today's trends. And selection bias, because data from more developed regions is overrepresented compared to the smaller areas. Even with all these biases, the overall accuracy across models averaged to 88%. Some stations reached over 95% accuracy, showing that the models are generalized well. Though isolated overfitting may have occurred in some places with less variability. To optimize our models, I have used gradient descent, which is a key optimization algorithm in machine learning. It works by iteratively adjusting model parameters to minimize the loss function, essentially reducing prediction errors step by step. In this case, gradient descent helped optimize temperature and weather condition predictions across all the weather stations. This algorithm was able to minimize the loss function to nearly zero, suggesting that the average temperature and weather patterns can be modeled as differentiable functions. This optimization helped reduce overfitting and led to more consistent accuracy across all stations. Next. So our first supervised learning model was K nearest neighbors, or KNN. It predicts outcomes by measuring the distance between new data points and their closest neighbors in the training set. Each prediction is then based on the majority class of its neighbors. In this case, whether a data was pleasant or unpleasant. So I have performed, I applied this model to all the weather stations using k value of 3 and achieved an average accuracy of 88%. It performed best in areas with stable climates, but for some overfitting has occurred, such as Sonblik, where the stations are quite smaller and the accuracy reached almost 100. But overall, KNN was our most reliable and accurate algorithm for this data set. So, the decision tree algorithm classifies data by asking features-based questions and splitting the dataset into branches, much like a flowchart. So each path from the root to a leaf leads to a prediction. in this case whether a day was pleasant or unpleasant. Although this model is easy to interpret, it became overly complex during training, creating too many branches. The training accuracy was about 46% and the accuracy testing was around 47%, indicating poor generalization. This suggests that the model was overfitting and failing to learn meaningful patterns. So pruning the tree or using ensemble methods like random forest could significantly improve the future accuracy. Um, the artificial neural network, or ANN, is modeled after how the human brain processes information. It contains input, hidden and output layers that learn relationship between variables. For this project, I have trained the ANN on data from the weather stations and tested different configurations, adjusting the number of hidden layers, nodes and iterations. The best test accuracy was 56%, while training accuracy remained higher, suggesting overfitting to the training data. While the ANN didn't outperform KNN in this case, it shows strong potential. With further optimization like regularization or more balanced data, the ANN could achieve higher accuracy in future tests. Also, to here we see a set of confusion matrices, one for each weather station. Each matrix shows the breakdown of accurate and inaccurate predictions for pleasant and unpleasant weather. For example, Sunblex matrix is entirely dark, indicating 100% accuracy, but this likely reflects overfitting, since that stations mostly experience unpleasant condition. These visualizations help us understand not just how accurate the models are all over, but also where they tend to make mistakes, such as false positives or false negatives. So to summarize our findings, machine learning algorithms show strong potential for predicting future weather conditions, with models reaching up to 88% accuracy. The KNN algorithm performed the best overall, while the ANN model can likely be tuned to improve in future iterations. Accuracy varied depending on geography. For instance, Songblik achieved almost perfect predictions, while Madrid was lower due to greater climate variability. Looking ahead, our next steps are to refine the model to reduce overfitting, explore unsupervised learning for hidden pattern detection, and more environmental features like wind speed and solar radiation. Ultimately, this research demonstrates how machine learning can support climate forecasting and help identify early signs of climate change. So, thank you so much for your time. This project has shown how machine learning can enhance our understanding of climate trends and help us prepare for the future. I'd be happy to take any questions and hear your thoughts.